So hello everyone. Today we are going to start with session number 27 in which we are going to see all the forming tool operations such as dimple, lower, drawn, cutout and all. We are also going to see our gussets and we are going to see how to make vents on the parts. So to start with I am going to make first tab here. Tab means we are going to make a base flange first. So I'll take center rectangle. Here we need to put the dimensions. So I'll take this value as 200. We'll increase it little bit. I'll say it as 300 here. Next we are going to go for this width 150 mm. Say close sketch. Now we need to apply the thickness. So I'll take this thickness as 1 mm only. Say finish and cancel. Next we are going to apply the appearance. So I'll select this feature and I'll say this body. I want this complete body which is going to be made. I want to make it by steel appearance. So I'll say it's steel. Select the part and say close. So here we have applied steel as an appearance. Next say home. Now we are going to select counter flange. We have already seen counter flange in last lectures. So anyone, if you want to completely learn the sheet metal, you can follow the last lectures in the playlist. There you can see all the previous commands of sheet metal. So here I'm going to make counter flange. We need to select the edge and the reference plane should be added at one end. So I'll take the front end here. Next we need to go for the line command. So we have drawn two profiles. This vertical line representing the vertical flange and this one as horizontal flange. We need to provide the dimensions also. So I'll take this height here as 100 mm. Say auto scale and OK. Next we are going to go for this dimension. I'll say it as 30 mm. We also need to consider that this line should be made from the upper point only. So I'll take this dimension from the base here. We have not included the thickness. So I'm including the thickness also here. I'll take it as 100 mm. So including thickness, this 100 sizes of vertical flange and of horizontal size is 30. Say close sketch. And we will say chain option and we are going to select this face here. Here you can see this complete part has been made. Next I'll say OK and finish. Now these horizontal flanges are coming at outer sides. We want them to be diverted at inner sides. So I'll just click and say edit sketch and instead of taking this flange at the outer side, I'll delete this one and I'll make it at the inner sides having the same dimension as 30 and the height reference was removed, so again I need to provide the height. I'll say it as 100 mm. Say close sketch and finish. Next we need to go and provide some gap also here. For that I'm going to say edit definition, options, miter corners and we need to provide one gap. So I'll say it as gap 0.5 mm. So we can see a gap of 0.5 mm is appearing. We also need to provide corner treatments for this. So I'll say finish. Next we are going to go for corner treatments. So for that I'm going to go on this option, that is two bend corner. We need to select the two bends of each side and we need to provide the type of corner treatment. So I'll select here as square cutout so as to give corner relief. I'll take this value as 4 by 4. Next we need to go on this sides also. Say finish and then select the sides. Say OK. Again select the other two sides after saying finish. So the corner treatments are now applied at each corner. Next we are going to make some vertical flanges also. For that we are going to select multi-edge flange. We need to select the flanges first, second, third and this one is the last one. Say OK and we are going to take vertical flanges here. So I'll take this height as 15 mm. Say finish and cancel. So we have made the box here. I need to apply some forming operations now on these spaces here. So today we are going to see these options only. For that only we have made this part. So I'll start with dimple here. First option is dimple. So I'll select this face as a planar face it is asking. So I'll take this as a planar face. We need to take center rectangle here. So the condition we require is that sketch should be completely closed. Not necessary that only rectangles are to be made. We can go with any closed profile. So I have made rectangle here. Say close sketch. And you can see the deformation. So here we need to provide the depth. So I'll take this distance as a depth only. I'm taking this as 8 mm. Here you can see. Next, whether you want this profile represents a die or represents a punch. If you show that the profile represents as a die, then this profile will completely come within the sketch, including the thickness. You can see here the symbol. But if I say that profile represents the punch, then the thickness will be excluded from the overall profile dimensions. So here you can see here this rectangle. Now this thickness is coming outside of this sketch. Suppose if I go for the first option again, then the thickness side has been flipped at the inner sides. So whether you want to represent this as a die or whether you want to represent this as a punch. So both the options are given here. I'll take it as a punch only this time. Next, for editing the corners, we need to go on these options. So if I want to make this punch as tapered one, so I'll provide the degree here. I'll set 5 degrees. Next, I need to provide roundings. So this is taking here as punch radius. So punch radius will come at the bottom side at this corners. So I'll take this punch radius as 1 mm. And we need to provide the die radius also. So again I'll go for the options. And here I'll take 1 mm as a die radius. Next, this includes side corner radius is also given. So this side corner radius for the punch stands for this one, this vertical corner. So I'll provide or include this one also here. Say OK now. And now this complete round is coming at the vertical sides also, having radius of 1 mm and the punch radius also of 1 mm. Next, whether you want to see it is inclined or not, then you can see here. We just need to orient the part and we will change the visualization mode. You can see here, these faces are coming inclined. They are not coming straight here with the punch. They are coming as inclined faces with the angle of 5 degrees. So from vertical, this angle is diverged at the outer sides with 5 degrees. This inclination or draft angle is taken just to withdraw the punch easily. It will not stuck in the part. That's why this taperedness has been provided. Again, we will change the visualization mode. So this was the first option, that was dimple. You can take it circular profile also or any closed profile required. Next, we are going to go for this drawn cutout. We are going to see this lower option later. Before that, we are going to see this drawn cutout. It is similar to dimple. The requirement is same, that we should have close sketch, but it will not have any bottom face there. Means the punch will cross the material through and through. So here for drawn cutout, I am going to select the option. Select the planar face or a reference face to draw the sketch. Next, we need to go and say any close profile again. So I am going to take this close profile here as a rectangle only this time also. Say close sketch. Instead of taking at the inner sides, I am going to go and take it as the upper sides. Here also you will get the two options, that is profile represents die or profile represents punch. If the profile represents die, then these walls will come within the sketch, and if the profile represents punch, then the thickness will be excluded from the sketch. That's why you can see here this sketch is coming within the walls. If I say first option, this sketch will come outside and the thickness will come within the sketch. So you can see the difference here. I'll keep it little bit inclined here before seeing the options. Then select the options command. Here we'll see provide taper angle as 4 degree. Now punch radius will not be included here. It is because the material is going through and through. This material is going as through all. So here we don't have punch radius as we are not having material at the base side. So die radius will represent this borders here, you can see here. This is given for die radius. I'll say it okay here. I'll zoom out and you can see there is no radius been given at the corners. So to include radius at the vertical corners also, we are going to go in options and we'll say include punch side radius. So for that I am going to say 2 as a radius. You can see here, say finish and cancel. Again I'll make it normal in position and you can see these flanges are not coming straight. Instead they are having angle of 4 degrees as we have taken draft angle in the options. Next we are going to go here on this face and we are going to see the next option, that is bead. Bead means you can go for the open profile here and the condition is that each corner must have 2D fillet so as to make this operation work. So I'll select this option bead here and we'll select this bottom face and now we'll make one sketch. So I'll take this line command, say smart dimension, go for this horizontal or vertical option. I'll take this as 35. Here we need to provide 96 as the dimension, so we'll make this length little bit smaller. I'll take it as 60 mm only. Provide this as a horizontal line. I'll say the relation as horizontal. Next, I'll go for the vertical relation again. So for that, you just need to select the option and select the points. Next, say close sketch. Before closing the sketch, if I directly say close sketch before putting the corner fillets here, it will show error. You can see here. So here one note is coming that it is not a valid profile. We need to make corners here. This error is because just we have not provided fillets in the 2D sketch. So for that I'll cancel this and we'll go for the fillets. I'll select the fillet option here. Need to select the corners. Next we are going to go for smart dimension and select the radius value here. I'll take it as 4. We are going to say equal if we required here. I'll change this value, instead of 4 I'll say it as 10 mm. Next we'll update this dimension again. This is because after giving the fillet the references are being changed. So I'll take this side and point and say it as 60 mm. From vertical side I need to apply one more dimension. So I'll take it as 50 mm here. Next, this also has 60 mm. Take this as 50 and lastly 55. So after putting up all the values, we are going to close this sketch here and you can see here one bead profile is coming. The cross section of bead profile we can change it in going options, and here you can see there are 3 options given and here is the preview of the 3 options. First one is circular, second is U shape which we have taken this time, third one is V shape. So I'll go for this V shape and we can increase the height and width. So this height is nothing but the depth which we can see here. So if I want to change this depth, I'll say it as 3. I'll take this bending radius as 1 only. And if I want to change the width, I will change the angle. So instead of 15, I'll take this as 10 degrees. You can see these profile dimensions are being updated. Next, if I want to change the profile directly, I'll go for circular one. First, we'll change the radius option. So here I'll change the radius and I'm going to say here as 4. And then we can change the depth also. So I'm going to take this depth as 2.5. So the height value should always be lesser than the radius value if you are going to take the circular profile. Say OK again. Next we need to provide the direction, whether you want this groove to be made at the upper side or lower side. So I'll select at the lower side only, say finish and cancel. So here the corner treatments are very necessary in this sketch, then only you can provide this option. And it is important because we can go for the open sketches or open profiles also using this bead. So this was one of the forming operation, that is bead. Next option we are going to see here is lower. So for that we need to make the line sketch first. So I'll select the lower, select the planar face on which we want to provide the lower here. So I'll select this face here. Next we are going to go for the lower line. So whatever width I require, I'm going to represent it by the line. I'll put up the dimension. So from the vertical side, I need to place it at 60 mm, and horizontally we need to place from the left side till this corner point, that is this line point. I'll take this value as 35. Next we are going to say close sketch. After closing the sketch, it is asking you the depth of the lower. So here we'll take this depth of the lower as 10 mm. Next it will ask you the height of the lower. So to provide the height, the maximum height we can take here is depth minus the thickness of the part. So depth we have taken 10 mm, minusing the thickness was 1 mm. So if we minus the thickness from the depth, the value will come 9 mm. So the height, maximum height we can take here is of 9 mm. Here you can see one yellow mark, exclamatory error mark is coming. It is because the height here, it has been taken as 29. You can see here in the dimensions. If I go for this 10 mm value also, it is showing the error. But if I take this value max to max 9 or below 9, this sign will automatically get removed, providing the height. So here the formula was you need to consider the depth and you need to minus the thickness from the depth. Whatever part thickness it may be, you need to minus it from the depth. So whatever value will come, maximum height we can refer by that remaining value. So I'll take it as 9 mm here. But as we have taken the depth at the lower side, so it is coming in reverse direction. We'll change the depth step. We can edit the direction of depth. I'll click in this option, and instead of taking at the lower side, I'll take it at the upper side. Now you can see this lower has been provided. We need to provide the punch radius also here. For that we are going to go for these options, and here we are going to include these roundings with the die radius of 2 mm. Here you can see this radius has been applied here. Say finish and cancel. So here one lower has been provided. These are used for ventilating the part. Now if I want to make this pattern, I'll go for the pattern option again. Select the pattern. We need to select the feature to be patterned. Say OK. Next we need to select the face on which we need to provide the pattern. Next I'm going to select the type of the pattern as fixed one here. Select the reference and we'll drag it here. It is asking the dimension and center to center distance in X and Y directions. So in X direction we are not going to edit the values. We need to provide the values in Y direction, in vertical direction. For that, and center to center distance I'll take it here as 30 mm and we'll provide this value as 3. I'll change this value. Instead of 30 I'll take it as 70 mm here. And here the number of entities we require is 4. Click on the direction option and you need to say close sketch. But here X references are also coming. We don't want columns here, so I'll edit this and say 1 only. Say close sketch and finish. I'll change the distance here. I'll say edit definition again. We need to say draw profile step, and in draw profile step we need to select this option. Select all. This will show again the edit definition options. Here I'll change the distance. Instead of 70, I'll take it here as 55 and entities as 5. I'll take 50 only. Say close sketch and finish. I'll change the appearance here. It is not properly visible, all the features. So I'll select this view, part painter, and instead of steel, I'll select here as silver and click on the part. Now the features are more properly visible. You can see here. Say close and finish. If you want to hide this base axis, just hide the base axis. So here we have seen the forming operations which were dimple, lower, drawn cutout and bead. We need to see this option, that is gussets. Before gussets, we'll make it flatten here. Go on tools option. Select flatten. We need to select the bottom face, reference face and edge reference also. This part is showing a flattened view of this particular entity. So you can see lowers at one end. This was the bead profile. This was dimple and this was drawn cutout. So here the flattened view is being shown. Next we'll unflatten it again. Now for gusset I'm going to take new part. Say isometric sheet metal. Say OK again. Here we need to select the tab. We'll start with the tab here. Say center rectangle. Provide the dimensions for the tab. I'll say it as 90 mm. Say close sketch. Say finish. Next we are going to go for bend. I'll make one line here representing the bending line. We need to provide the dimension from the edge reference. Take it as 45. Say close sketch. I want to show the moving face and direction whether I want it upside or downside. So I'll take it at upper side and say finish and cancel. Next we are going to go for the gusset option. So for gussets, and here you have gusset. We need to select the bend step, means the bend on which the gusset is going to be applied. Next the distance. So I'll place it somewhere here. Then need to provide the distance also. I'll take it as 24 mm. So from the corner you can see here the reference is coming from the left side corner till the center of the rib. Now for changing the dimensions and profiles of the rib, we need to go in these options. And here you have automatic profile depth. So here the depth is coming as 3. I'll take it as 20 mm. The width, I'll take it as 6 mm. It will ask whether you want the square rib you can see in the demo here, or you want a round rib with round face at the front side. Square or round face. So gusset shape you can provide here. I'll take it round only. And you want a tapered angle as it is going to be punched inside. So you can provide the taper angle also for easy withdrawal of the punch. So I'll take it as 2 degrees here. If I want to include the rounding, this rounding, you can go for this rounding. So I'll say the punch radius as 1 mm and die radius as 1 mm. So this fillet roundings will be included there. You can see at the edges. Say OK. And this gusset has been made here. You can see here. Say finish and cancel. You can mirror this gusset on the other side. For that I'll select the mirror option. Select the features. Say OK. Select the reference plane. For that I'm going to put on the planes. Go for this plane option and finish. So here you can see these gussets are being provided. They are punched inside here. We'll hide the reference planes again. Again, if you want to change the size of the gusset, you need to go and say edit definition and options. You can change the size. So instead of 20, I'll take 16 mm this time. So the height and width of the gusset is being changed to 16 mm. Say finish. We'll go for flatten again. For that, go on tools option, say flatten. Select the base reference and edge. So in flatten, you can see these gussets are not being shown. When you unflatten them, this gusset will be visible again. Again flatten, and see the gussets are not being shown. So this was gusset option in forming operations. Last we are going to see here is this cross break. For that we are going to refer some images. So here you can see in this image, one wash basin bottom side is being shown, having these cross corners here. They are forced at the downside and are having bending radius with some obtuse angles. So in practical purpose, we cannot show this in software. We just need to show the bending radius and angle and the direction at which we want to bend this part. The purpose of providing the cross break is to maintain the stiffness of this part at the bottom sides. So here we'll go on the solid edge part again. We'll remove this bend. Say remove. We'll also remove the gussets here as well as the mirror. Now for providing the cross break, we need to make one sketch there. I'll say this face as a sketch and we need to draw the cross lines here. The second line Then say close sketch and finish. Next we are going to go for the option that is cross break. Select the face. Then we need to select the sketches also. Say OK after selection of face and then go for the sketch selection. Say OK. Here we need to provide the angle. So I'll take this as 3 degrees bend from the bottom side. So it is asking you whether you want this bend to be made upper side or at the lower side. Usually these are made at the lower sides only. So I'll flip the dimension of the arrows at the bottom side and click here. Say finish and cancel. So here only this X mark will appear on the part. In actual they are not going to be bended as shown in the photo here. These were the cross breaks provided for maintaining the stiffness at the required faces. So this was cross break. Next we are going to go for vent. We need to make some sketches over the face. So we'll start with this sketch. I'll select this sketch, say this face, and we are going to make some circles here. For the larger diameter, we'll drag them a little bit more. The circle should be provided by giving the dimensions only. I am taking it directly just for the teaching purpose. We'll move this feature a little bit upward. So here I'll say close sketch. And for positioning this drawn cutout again, I'm going to say edit sketch. And we'll take some dimension from the upper side. So as to move this upper side, I'll say it as 150 mm there. Say close sketch. Say finish. Now for the circles also I'm going to say edit sketch. We are going to move all the circles a little bit upwards. So for that I'm going to select move command here. Select the entities to be moved. Select the base reference. I'll select this center as a base reference and we'll take all the profiles here at this position. I'll draw some lines also here. These lines will act as ribs. We'll make 2 more lines with angle of 45 degrees. Next we are going to mirror these lines on the other side. Select mirror. Say finish. Again select both these 2 lines now and we are going to mirror them on the opposite side. Select mirror, select the reference line and finish. So here we have made some circles and some lines at equidistant angles. These lines will act as ribs and the circles will act as a spars. We will see both the options ribs and spars in vent option. So for that we are going to switch the interface here. I'll go for tools. First we'll say close sketch. Say finish. And then we are going to go for tools so as to switch the interface. As this vent command is not given in the sheet metal interface, you can see here there is no option for the vent being given here. So that vent option is given in part modeling tab. So for that I'm going to switch this, say tools and switch the interface. So for that say tools, select this option, switch to, say yes, and the interface will be switched to part modeling here. You can see here. Now in part modeling, in thin wall feature you will get that option, that is vent option. I'll take this part little bit at the offset side so as to show all the references here. So in vent, it will ask you the rib thickness. So ribs are nothing but the lines here. So I'll take this thickness as 1 mm. Spars thickness I'll take it as 1 mm only. We'll change it later if we require that. the depth will take the thickness value only. So whatever was the thickness value of the part will take this depth value as same. I'll take this as 1 mm only, as we have taken the thickness also as 1 mm. Both for ribs and spars the depth will be same. Next, if you want to fillet or make rounds on the corners of the vent, you can provide this option, that is round option. I'll put it off only this time. Later we'll edit them. I'll say it okay. Next you need to follow the prompt bar. It is asking you to define the boundary. So always the outer circle must be taken as a boundary, or any outer profile shape can be taken as a boundary. Then say OK. Next it will ask you to select the ribs. So for ribs I am going to select the lines, as we have discussed earlier only that these lines will act as a rib. Say OK again. Next it will ask you for spars. So for spars I am going to select these circles here. Again say OK. Next it will ask you the cut direction. So we have made this sketch on the upper face here. So it will not cut at the front. So it will cut on the other side only. At the left side I'll click here. Next I'll say finish and cancel. So you can see one grid is provided here. It will act as a vent. We'll see it through section view. I'll go on PMI option. We'll select the section plane as Y. I'll select the section plane on the keyboard. I'll rotate this section and say OK and finish. So here you can see this vent is been provided. We'll change the thickness for the vent. So again we'll select the vent, say edit feature, say options, and you will change the thicknesses over here. I'll set this as 2 mm and spars also of 2 mm. Now you can see they are a little bit thicker now. We'll provide the radius also, round radius. I'll take it as 0.3 mm. So you can see these corners are being filleted here. All the corners of the vent are being filleted by radius 0.3. So that roundness was the option for providing the radius here. Say finish. If you want to increase the smoothness of this arc, you can see here they are not being shown as smooth chords. So if you want to change the smoothness over here, you just need to go and select view option. So this option is coming over here, sharpness set. You just need to say finer display. Say yes. You can see the smoothness of this arc now is been increased. The smoothness has been increased now. More finished part will be seen here. If I want to put off the sections, I'll put off the section here. We'll off the sketch. And this vent is been provided. Put on the section again. Just go in model tree and put on the section. You can see vent is better being seen by section view only. So these were some of the options which were remaining in sheet metal syllabus. Now we have completed all the options in sheet metal. We'll continue with making more objects in sheet metal so as the practice can be continued. So to learn more about sheet metal, you just need to follow the playlist of the Solid Edge. Please do like, share and subscribe the channel 4 Dimensions Infotech. Till then, thank you.